Dear students, in our previous class we have discussed about the linear data structures and non-linear data structures and also the operations performed by non-linear data structures. But today we are going to discuss a classification of data structure by name arrays. In your previous year, that is in first year PUC, you have already learned about arrays. What are arrays and how many types of arrays are there? The same thing here again repeated with some additional topics of arrays. So come we shall see what is an array. An array is a collection of homogeneous elements with unique name So an array can be called as a collection of homogeneous elements. You have already know that homogeneous and heterogeneous. Homogeneous means same kind of elements. Okay, it is a collection of same kind of elements with unique name. Unique name means every element is having its unique and separate name. Okay, the elements of an array, the elements are arranged. Okay, or the elements of an array are are arranged one after the other in, in adjacent memory locations in adjacent memory locations. Okay, here the elements are arranged one after the other in adjacent memory locations. Look here, take this as an array. We can call this as an array. Okay, like we can store it as some values we try to store 5, 12, and like that 16 and so on. And this can be taken as k of 0, k of 1, k of 2, like that up to a of n minus 1. Okay, and it's having different addresses. This is subscript. Okay, this is subscript. Okay, then elements, these are called as elements. Then address. Okay, they are the collection of same type of elements is array. Okay, then the elements are arranged one after the other in contiguous or adjacent memory locations. One after the other, the elements are stored. This is the rule of an array. And also the elements which are present in array, the data items which are present in array, these data items we can call them as elements. Okay, and the representation of array can be done by the index or the indices, and also the representation of array can also be known as the subscripts. The value which is given, okay, to represent an array, that value we can call it as subscript, and the data items included in array are called as elements, and the location where the data items of an array are stored, and that locations we can call them as the address. Like this we can represent the array here. Hope you have understood. Array is a collection of homogeneous elements with unique name. Okay, unique name you have to understand. Unique name means array data element is 5. Okay, it is having a unique name a of 0, and array data element 12 is having unique name a of 1. Okay, the subscript which is given to the data element of an array, that is called as an unique name. Okay, look here, homogeneous elements, same type of elements, okay, with unique name. Every element is having its own unique name. Element and element unique name, element its unique name, element its unique name. Like this array can be represented. The elements are arranged one after other, one after the other, okay, in adjacent memory location, means one beside the other. Okay, here the data items of an array are called as elements, and the indices or the unique names which are used to represent the data items of an array, they are called as the subscripts. And the location of the data elements, location of the data elements, that location we can call it as the address of an array. Okay, so now how many types of arrays are there? You have learned in your first PUC that there are three types of arrays. So now we shall see how many types of arrays are there, and we will try to discuss one by one. Types of array. Types of array. First one is, okay. First one is one-dimensional array. One-dimensional array. The next one is two-dimensional array. Two-dimensional array. The next one is three multi-dimensional array. Multi-dimensional array. Okay. In your syllabus here, we are going to discuss the three dimensions of arrays. Okay, one-dimensional array, two-dimensional array, and multi-dimensional array. Now we shall see what is meant by one-dimensional array, and we have to look about one-dimensional array in detail. Okay, an array with only one row or column. Okay, an array with only one row or column is called one-dimensional array. Is called one-dimensional array. Look, array with only one row or column, as I have already shown you. Okay, we'll take some different values now, or if you want I will take the same values, 1 2 3 4 5 12 and 16. A of 0, A of 1, okay, A of 2 up to A of n minus 1. Okay, then address is 100, 101, 102 up to 106 and so on. Okay, this is called as subscript. Okay, the next one is elements. Okay, these are elements, and this is called as the address. Look, this can be called as a one-dimensional array. Why do you call this as one-dimensional array? Because according to the definition of one-dimensional array, okay, the array should have only one row or just one column. This array is having just one row, so we can call this as a one-dimensional array. Like this, if you see the array either in a single row or in a single column, we'll write in column wise also. Okay, we shall write like this: A, Okay, take any values, 2, 5, 3, 8. Okay, address will be taken as 100, 101, 102, 103, and this can be taken as 110, a of 0, a of 1, a of 2, and a of 3. See, the same thing. This is row and this is a column. Okay, these are called as address. Okay, and these are elements. This is subscript. Arrays in row. This is in column. So this type of array we can call it as one dimensional array. Okay. It can also be represented as it is a finite collection of. It is a finite collection of n number of elements. N number of elements. N number of elements means it may be any number of elements, but should be finite collection. Finite means we can able to count. Okay, we can able to find out. That means finite collection. Okay, n number means any number. Okay, here there are 4 numbers, here also 4 numbers, like that, uncountable numbers. Okay, but it should be finite collection. We can able to find. Okay, that type of an array we can call it as one dimensional array. Here some rules are there for one dimensional array. What are the rules for one dimensional array? I will write above here. Okay, first one is elements are stored in contiguous memory locations. Contiguous memory locations. Okay, this is nothing but the elements must be stored continuously without giving any gap. That is called elements are stored in contiguous memory locations. And the next rule is elements can be referred. Elements can be referred by indexing. Elements can be referred by indexing. Indexing means subscript should have unique representation. These are the indexes of every data element. See, these are the indexes of every data element or the subscripts of every data element. Elements can be referred means we will not directly write the element in the array. If you want to, just I will give you example. If you want to represent 2 in an array, then you will write the index a of 0. If a of 0 is there, then we have to think that this is number 2, an element 2. Okay, here 12 is there. If you write it as a of 1, okay, then this may be think it as the element 12. We will not represent the data item or we will not represent the element of an array directly. Okay, we will refer the elements by giving their indexes. Okay, these are the rules of one dimensional array. Come, we shall see the syntax of one dimensional array. How can we give the syntax of one dimensional array? Okay, the syntax is first we have to see data type. Okay, data type. Then array name. Data type, array name. Okay, array name. Then size. data type, array name, and size. This is the syntax. Data type, what are the data types? Data type, it may be integer, character, or string, anything it might be. Okay, so we will take data type as integer. Okay, then leave space. Array name is a. Okay, array name is a here. See, array name is a in indexes. Okay, then size, give as you require. Any size you want, you can give, and close it by semicolon. Like this, we have to give the syntax of an array. Okay, syntax of one dimensional array. After taking data type, we have to leave one space. In data type, there must not be space. In array name, there must not be a space. After in between array name and size, there should not be a space. Like this, we have to give the syntax of one dimensional array. So hope you have understood up to here. Now we shall see. Some features of arrays are there. What are the features of arrays? We shall look at the features of arrays because you have already clear about this. Okay, subscript, elements, and address. Then subscript, elements, and address. So we shall see now the features of arrays. Features of array. Okay, the first thing is array size should be positive number. Array size should be positive number only. Array size should be positive number only. For example, while giving array, okay, int a of 10. Okay, this is the size of array, right? Okay, in the size of array, the number should be positive number only. Here we will not assign any negative value like minus 10 or minus 5 like that. Minus 10 or minus 5 like that. We should not give array size as negative numbers. Only the array size should be of positive number. The next thing is, okay, string array always terminates with null character. Null character means this is /0. Null character means it is /0. So string array. Okay, what is character and what is string? Character means it is a single character. String means a sequence of characters. Okay, if you write a string array means sequence of characters, just like second PUC. Okay, this is an array. Okay, I will write in array form. Okay, second PUC. Okay, this is an array. This is a string array, right? Second PUC. And the string array should always terminate by the null character. Okay, the end of string array should be the null character. That is the second feature of your arrays. Okay, array size should be of positive number. Then the string array always terminates with null character. Null character means it is 0. Null character can be denoted like this. Then the next thing, array elements are counted from counted from 0, okay, 0 to n minus 1. 0 to n minus 1. As I have already shown you that a of 0, okay, a of 1, a of 2, like that up to a of n minus 1. Okay, here you can give them as arrays a of 0, a of 1, a of 2, 15, 12, 18, 20, like this. Okay, subscript. Always, okay, array elements are counted from 0 to n minus 1. Like this, we can count the array elements. And the last feature is useful for multiple reading of elements. Okay, what is meant by this multiple reading? Multiple reading means in an array, okay, it should be allowed that, okay, if a is given in the, or number 5 is given in the first element, and the same element can be repeated again. This is called as multiple reading of elements. The same elements can be repeated anytime and anywhere in an array. That is called as multiple reading of elements. Array should be in that type, okay. In the array, the elements can be read multiple times. Okay, useful for multiple reading of elements. Okay, same element. If you want to repeat any time in an array, you can able to repeat. That is the last feature of your arrays. Array size should be positive number. No negative number should be given. Array string always terminate with null character. String should always terminate with null character. Elements can be counted from 0 to n minus 1. It should not be counted from 1. Okay, elements should always be counted from 0 to n minus 1. Then useful for multiple reading of elements. If you want to read an element with multiple times, okay, then the permission should be there in an array to repeat the same element multiple times. This is the feature of the array. These are the most important features of arrays. Now we shall see. Calculating the length of an array. Calculating the length of an array. Okay. Here, calculating the length of an array. The length of an array. How will you calculate the length of an array? Okay. A formula is there. L is equal to UB minus LB plus 1. L is equal to UB minus LB plus 1. This is the formula to calculate the length of an array. By using this formula, how will you calculate the length of an array? We will take on array as an example. Okay, I will take 5 elements of an array. Okay, here 6 elements are there, no problem. C, D, E, F. Okay, and the address will be taken as like this: 1000, then 1001, 1002, then 1003, okay, then 1004, then 1005. And how the subscripts can be given? Okay, by we will take the array name as S. Okay, it is not necessary to take it as A itself. We can take any name as array name. We'll take, but it must be a single character. S of 0. Okay, then S of 1, then S of 2. Okay, then S of 3, then S of 4. Okay, then finally S of 5. Look here, we are storing 6 elements, okay, in different addresses by giving different indexes, different subscripts. So here, if you want to calculate the length of an array, UB minus LB, you should think what is UB. UB means upper bound. Upper bound. Okay. Then LB means it is lower bound. Lower bound. Okay. L is equal to UB minus LB plus 1. Plus 1. Here, UB upper bound means, okay, the subscript or the index of an array with highest number. Subscript or index of an array with highest number. See, this is the smallest number. 0, 1, 2, 3, 4, 5 is the highest number. 5 is the highest number. So this can be taken as UB upper bound. Okay, what is the lower bound here? The smallest number of an index or the subscript, that is 0 is the smallest number. This can be taken as lower bound. Upper bound and lower bound. And this is equal to, which is equal to, okay, we can take this as, yes, 5 is there. So upper bound is 5. Okay, minus lower bound is 0. 0 plus 1, which is equal to 5 minus 0 is 5 plus 1, that is equal to 6. The length of an array is 6. Look, 1, 2, 3, 4, 5, 6. Like this, we can calculate the length of an array with the help of this formula. L is equal to UB minus LB plus 1. You may get for 1 mark question, write the formula to find the length of an array. Or it may be asked for 2 marks like that. How will you calculate the length of an array? Then you need to explain all these things. You have to write the formula. Then you have to define upper bound and lower bound. By giving this example, you have to calculate the length of an array. This would be for your 2 mark question or maybe for 1 mark question. Like this, you have to represent or calculate the length of an array. Now we shall see. How will you represent the one-dimensional array in memory? This is calculation. Now, representation of one-dimensional array in memory. Representation of one-dimensional array in memory. Okay. Representation of one-dimensional array in memory. How will you represent this? Okay, I will take the same example. Okay, now just remove this. I'll take the same example. For this example, I'm going to explain you how will you represent the one-dimensional array in memory. Here, there is a formula for this. Location of, okay, location of A of P, okay, which is equal to, alright, like this, little bit. Location of A of P, okay, which is equal to base A, okay, base A plus W into P minus LB, okay. LB means this one, the lower bound, okay. This one is the upper bound. Okay. Location A of P, okay, is equal to base A plus W into P minus LB. A of P. This A of P can be taken as the index of an array. Okay, A of P represents index of an array. Base A, okay, base A means the starting address of an array. Okay, A of P is the index of array. Base A is starting address of an array. W means number of words in an array. Number of words in an array. Then P means, here A of P means, I will show you. A of P, okay, which is equal to, we want to, okay, find the location of D. Okay, we will try to find the location of D. If we if you try to find the location of D, then we have to get the answer location as 1003. Okay, because D is present in 1003 location. If we get the answer 1003, then our problem is correct. Okay, D is present in 1003. By applying this formula, we have to substitute for 1003. Here, A of P is equal to subscript of D, that is S of 3. Okay, S of 3. This is array name, this is size. Okay, okay, I'll write like this. A is equal to array name. Okay, then P is equal to size. Okay, base is equal to starting location, starting element location. Okay, starting element location, first element location. Then W is equal to number of elements in array, number of elements in array. Okay, then LB is equal to lower bound, LB is equal to lower bound. Now we shall see. A, array name is S here. Okay, this A can be taken as S. Okay, taken as S. P, size means we are calculating for D. Size is 3. Array name is S, size is 3, which is equal to 3. Okay, then base, starting element location. Starting the first element location, that is 1000. Okay, then W is equal to number of elements. 1, 2, 3, 4, 5, 6. Number of elements. Lower bound is 0. Okay, now applying all these things in this formula, we will try to calculate how this can be taken. Okay, this is LOC. Okay, LOC. A of P means we are calculating for D, that means S of 3. Okay, S of 3, which is equal to base A is 1000. Okay, plus W is number of elements, 1, 2, 3, 4, 5, 6. Write down 6. Okay, 6. Here P is size is 3 here, 3. Minus LB is lower bound, that is 0. 3 minus 0. Okay. Sorry, one thing we have to look clearly. W means, okay, number of words in an array. W is equal to number of words, so only one word is here. Look, only one word is there. A, B, C, D, E, F. It is a single word. We can be taken as A, B, C, D, E, F. It is a single number of words, not the number of letters. W is equal to number of words. Now we have to calculate the length of an array. Okay, S of 3, which is equal to 1000. Okay, plus 1 into 3. 3 minus 0 is 3, which is equal to 1000 plus 3 ones are or 1 threes are 3, which is equal to 1003. So finally we have got it as the location of D is 1003. Like this, representation of one dimensional array can be done with the help of formula. Location of A of P is equal to base of A plus W into P minus L P. Okay, we have to apply. A of P is, yes, the element which we search, S of 3. That's subset. Then base A is the location of the first element. Then W is number of words in an array, not the letters. Okay, here this complete thing is one word only. That is one. P means the size of the element. Okay, 3. So finally, D is present at location 1003. By all the calculations, we have got that D is present at the location 1003. Okay, dear students, as we have done some operations on primitive data structures and non-linear data structures, same as here also, now we are going to do some operations of one-dimensional array, operations on one-dimensional array. One-dimensional array. Okay. Same as the non-linear data structures. Okay, traversing. Okay, then insertion. Okay, then deletion, then searching, then sorting, and finally merging. Okay, traversing. Okay, accessing each data item exactly once is called as traversing. Okay, accessing each element exactly once to perform some operation. To perform some operation. Okay, same as linear data structure. Inserting a new item, or adding a new item. Okay, inserting or adding a new item, new element in an array. Okay, if you want to insert a new element, this insertion will be done. So next, deletion, removing an element from the array. Okay, if you want to remove the element, then you have to use the deletion. Then searching. Okay, finding the location of an element in an array. Okay, finding the location of an element in an array. I had shown you location of A of P, which is equal to base A plus W into P minus LB. We have found the location 1003 of the element D. Like that, we will use searching. Okay, searching, finding the location of an element in an array. Sorting, arranging the or sorting. Okay, we can take it as arranging the array elements in in some some order. Arranging the array elements in some order. Then merging, combining one or more one or more array. Okay, array, combining one or more array to form a single array, to form a single array. Okay, but in non-linear data structure, what we have did, there we have used the elements in given collection of elements, but here we are using elements in an array, and finally combining one or more arrays to form a single array. There we have used elements in given collection of elements, but here we are using arrays in given collection of arrays, or elements in an array. Hope you have understood up to here. Later, we shall discuss our new topic regarding this. If you have any doubts, you can ask me personally. Thank you.